You know that one app on your phone, the one that just works every single time, and then you think about all the others that are slow, buggy, or just plain frustrating. What's the difference? Well, it's not magic, and it's definitely not luck. Today, we're going to pull back the curtain and look at the hidden structure that makes great software possible.
Ugh, we've all been there, right? You're right in the middle of doing something important and bam, the app just crashes. It freezes up, it disappears, it's gone. It's such a universal feeling of frustration. But why does it happen so often? Well, the answer is actually simpler and a lot more chaotic than you might think.
And this quote right here, it just hits the nail on the head. The main villain in our story is chaos. When there's no plan, no structure, development teams are pretty much just winging it. And that haphazard, anything-goes approach is the #1 reason why so many software projects go completely off the rails, delivering a buggy mess, or just failing altogether.
All right, so here's the game plan. We are going to tame that chaos. First, we'll dig into the problem itself. Then, we'll figure out what quality even means. After that, I'll introduce you to the two heroes of our story, the SDLC and SQA. And finally, we'll see how this all comes together in a real-world example.
So let's kick things off with a little history lesson. Because this struggle to build software that you can actually rely on, it is not new. Not at all. In fact, the industry has been wrestling with this for more than half a century, going all the way back to a time they called the software crisis.
Picture this. It's the 60s and 70s. Computers are getting way more powerful, and the software people are trying to build is getting incredibly complex. But the methods to build it just hadn't caught up. So projects were always late, they were blowing their budgets, and a lot of the time, the final product barely even worked. This crisis was a huge wake-up call that made everyone realize, okay, we need a much better way to do this.
And here's how that chaos leads to disaster. It's like a chain reaction. It all starts with one small thing, a human error. A developer makes a tiny mistake. That mistake creates what we call a fault, or a bug in the code. And then, when the system runs that piece of buggy code, you can get a total system failure, the crash. It's just wild how one little slip-up can bring the whole thing down. Okay, so we know the problem is chaos, and it leads to failure. But what are we aiming for? What does it even mean for software to be high quality? Because it's about so much more than just, it doesn't crash.
This right here is a really important distinction to make. Look, pretty much any app can be functional. They can check the boxes on a list of features. But high-quality software, that's a different beast entirely. It's reliable, it's intuitive, it feels good to use. And, this is a big one, it's easy for other developers to maintain and update down the road. It's about the whole experience.
And that amazing experience is really a mix of all these ingredients. It's not just about correctness, does it do what it's supposed to do? It's also about usability. Is it a pain to use or is it a joy? Reliability, can I count on it every time? And maintainability, if something breaks, can we fix it easily? Real quality is getting the balance of all these things right.
So how in the world do you achieve that balance? Well, you need a blueprint, a master plan. And in the software world, that plan is called the Software Development Lifecycle, or SDLC. This is the first hero in our fight to conquer chaos.
The SDLC is basically the project's roadmap. You wouldn't try to build a skyscraper without a detailed blueprint, right? It's the same idea. It takes this huge, complicated job of making software and breaks it down into clear, manageable stages. It gets rid of the guesswork and makes sure everyone is working toward the same goal.
And here's what that roadmap usually looks like. It flows in a logical order through these 6 main phases. Now, this classic step-by-step approach is often called the waterfall model. A lot of modern teams use more flexible approaches, like Agile, where they loop through these stages in smaller bursts. But no matter how you do it, these core stages are the absolute foundation.
That first step, planning and requirements, you could argue it's the most important one of all. This is where you figure out what the software actually needs to do. You talk to the people who will use it, you define all the features, and you get it all down on paper. If you mess this part up, you could build a flawless piece of software that nobody actually needs. So, once you know what to build, the design phase is all about figuring out how to build it. This is where the technical architecture gets planned out. And then comes development, the fun part, where the programmers actually start writing the code, turning that design into something real and tangible. And finally, we hit the home stretch with these last 3 stages. The testing team becomes a team of bug hunters, trying to find all those errors and faults we talked about. Once it gets the green light, it's deployed, released out into the world for people to use. But the job's still not done.
Maintenance is all about supporting the app, fixing any new bugs that pop up, and adding features over time.
But here's the thing. Having a great blueprint is one thing. You also need someone making sure that people are actually following it correctly. And that's where our second hero comes in. Software Quality Assurance, or SQA.
Now, this is a super important point. SQA is not just about finding bugs at the end of the line, it's about preventing them from ever happening in the first place. It focuses on the process itself. Is the team following the SDLC? Are they meeting quality standards? SQA is like the guardian of the process, making sure the entire system is built to produce quality from day one.
Now, let's be real. Implementing a strong SQA process does take an upfront investment of time and money. But the payoff? It's huge. By catching and preventing problems early, you save an unbelievable amount of time and money you would have spent fixing them later. The end result is just way higher quality, way more reliable software.
Okay, all this theory is great, but let's make it real. Let's imagine we've been hired to build a mobile banking app. This is a project where there is absolutely zero room for error.
I mean, the stakes just don't get any higher, right? We're talking about people's money, their financial lives. The app has to be rock-solid secure, totally reliable, and simple enough for anyone to use. Chaos is not an option here. We need a process.
And this is exactly how that process keeps everything safe. In the requirement stage, we define critical things like users must be able to pay bills securely. Then in the design stage, we plan for things like fingerprint login or two-factor authentication. Then the SQA team comes in and just hammers on the testing, making sure every single transaction is secure. And even after the app is out, the process continues with updates and bug fixes. Sticking to a process like this helps you dodge all these classic mistakes. When teams are under pressure, they're so tempted to skip stages to save time. But that's just an open invitation for chaos to come right back in, focusing only on features while ignoring if the app is even usable. These are all shortcuts that lead straight back to a bad product.
And that brings us to the big takeaway. The difference between that app you hate and that app you love isn't some random accident. It's discipline. It's the direct result of a team committing to a structured process like the SDLC and having the SQA there to make sure that process is actually being followed.
So the next time you're using an app that is just a joy, it's fast, it's reliable, it never crashes, just take a second to think about the invisible structure that made it possible. And ask yourself, is this thing a product of chaos, or is it a quiet masterpiece of process?